Our objective is to be able to simplify using inverse trig functions and also to solve. When we simplify and we're using this symbol to represent the inverse function, then we only get a single answer. But when we solve, we oftentimes either have a restriction that tells us how many answers to give, or it might be multiple or even infinite number of solutions. So let's start with these that give single answers. We have to know what quadrant we're dealing with, because on these different ones, the trig functions are positive in 2 quadrants and negative in 2 quadrants. So sine, we're going to be using from negative 90 degrees to 90 degrees. That's in quadrants 1 and quadrant 4. So what we want to know is when we have a positive value, we're going to do it in quadrant 1. Negative value we'll do in quadrant 2. So we get in quadrant 4, so we list it as a negative angle when we're doing the negative value. Now cosine, on the other hand, it uses positive and negative quadrants for quadrants 1 and 2. So cosine goes from 0 degrees to 180 degrees if we're dealing in degrees. Again, this will use degrees here, but we could also have radians. So for this one, quadrant 1 is where cosine is positive, quadrant 2 is where cosine is negative. And then lastly, for inverse tangent, tangent is, we're going to use the same ones as we do for sine, so it's going to be from negative 90 degrees to 90 degrees. And so for this will be quadrant 1 and quadrant 4. And so tangent is positive in quadrant 1 and it's negative in quadrant 4. So those are the quadrants we'll use to come up with our single answer. So if we're looking here at inverse sine of 1/2, what you're doing is you're finding the angle that produces a sine that's 1/2. So if I look here at my unit circle, here's 1/2, but also here's another 1/2. So there's 2 angles here that look like that could give me a possible answer. We have to pick only one of them for it. That's where this helps out. If we've got a positive value that we're working with, we're going to use the first quadrant value. We're not going to worry about the 180. We're going to get 30 degrees. So the calculator will automatically give you that value, but we can we can see using these quadrants, we can do it off the unit circle as well. Now, inverse tangent of 1. Tangent, as a reminder, is sine of theta over cosine of theta. So we're looking where sine theta and cosine theta are both equal to each other. So remember, with our ordered pairs being cosine first and sine second on our unit circle, we're looking when the second one and the first one are the same. That's right here at 45 degrees. And then also down here at 225 degrees, they're the same. They're negatives, but when you put one over the other, sine over cosine, you get equal to 1. So this answer, because we have 2 possibilities, I'm going to use, notice for tangent, I'm going to use the first quadrant value for a positive value here. So this one I'm not going to use, I'm going to use the 45 degrees. And again, your calculator will tell you that. If you go ahead on your calculator and do inverse tangent of 1 and you're in degrees, it will give you that 45 degrees. Now let's do inverse cosine of 0.3. We don't have that on our unit circle. So we do want to turn to our calculator here, and we're going to go ahead and do just the inverse. Make sure you're first of all in degrees, because I'm doing my problem in degrees here. If you're in radians, use that. So I'm going to do second cosine, and I'm going to put 0.3 in this, and now I get a value of 72.5, so about 73 degrees. So this automatically gives me, notice, a value for cosine in the first quadrant for that. All right, so that's how we use both the unit circle and your calculator to get these values for simplifying, where you get one answer. Now let's do some solving problems. Solving, you're going to get multiple answers unless the directions restrict what your answers are going to be between 2 values or something like that. So the steps are, first of all, get the trig function by itself, then use the inverse trig function, and then check the quadrants for multiple answers. All right, so for this one, so I have to know when cosine and sine and tangent are positive and when they're negative, because I might get it in different quadrants. All right, so for this one, I'm going to go ahead and subtract 1 from both sides. So I get 2, divide by 2, you get, when does cosine theta equal to 1? Now, if you look at the unit circle, this could help us on this. We're only going to get a single answer for this because if you look at on the quadrants, these values, cosine is equal to 1 here at 0 degrees or 360. So you could give either one as your first answer. So theta is going to equal 0 degrees, but then I've got to give every coterminal angle with it. If I add 360, it will also be an answer. If I add 720, that will be an answer. So I want all multiples of 360. So we'll say 360 times k, where k is an integer. Now we won't always say that k is an integer, but that's what we use k here to say we're going to multiply by 1 or by 2 or by 3 to keep getting those coterminal angles. Let's do the next one here. Let's subtract square root of 3 from both sides, and then divide by 2. Sine theta is equal to negative square root of 3 over 2. Let's look back at our unit circle to see when does sine equal negative square root of 3 over 2. And I'll go ahead and circle these in green. So when you look at sine being the second one, notice that sine equal to negative square root of 3 over 2 right there. That's going to be 240 degrees here. And also negative square root of 3 over 2 here at 300 degrees. So there are two answers, and we know that sine is positive in quadrant 1 and 2 if we use the memory help of saying all students take calculus, all sine, tangent, cosine for positive values. Sine's positive in the top 2 quadrants, it's negative in the bottom 2. So I get these two answers, 240 and 300. And so when I list my answers, 240, and I also list 300, now I've got to go ahead, because I haven't restricted it, I'm going to add 360k onto each one of these. So this would be my answer when I'm dealing with the negatives for sine. All right, let's do this last one here. And again, sometimes you'll use your calculator, sometimes you use the unit circle. This one I'm going to use the calculator for it. And so for this one, I'm going to go ahead and divide by 5 on both sides. So I get tangent of theta equal to 7/5. Now I'm going to do the inverse tangent of both sides. Now remember that inverse tangent on my calculator will only give me one answer. So what I want to do is check out when what I will add on to get the different ones. So let's go ahead and do inverse tangent. So we're going to do second tangent of 7 divided by 5. Okay, so for this one I get 54.5. Let's do it to 1 decimal place, so 54.5 degrees. Now, let's see what I add on each time for this one. You're going to want to say 360, but you're going to miss something with that because the period of tangent is 180. So since the period of tangent and cotangent is 180 degrees, this one we're going to add on 54.5 degrees plus 180 degrees times k, because its period is smaller. Just a quick look at the graph to see where that comes from, okay? So here's one, it's a period, here's the next period, and then I keep going, I get other periods. Notice when I do this, if I want to know the inverse tangent of 7/5, so that's when I have 7/5, there's an angle here. That angle is 54.8 or 54.5. Notice that the asymptote's at 90 degrees, and so I'm going to get another time it's at 7/5 here. Notice that's 180 added onto it. And then when the next one comes like this, I'm gonna hit it again, and I'm gonna have to add another 180, so it keeps repeating that there are extra answers every 180 degrees. Last thing I wanna add on to it is if you're not using your calculator, and if you are using a calculator and you're gonna get these, you gotta know, for instance, on this one, that sign is negative in these two quadrants. And so when I do it on my calculator, let's go ahead and do the inverse sign of this negative square root of 3 over 2. So second sign, and I'm going to do negative square root of 3, and then get out of the square root, divided by 2. Okay, when I do that, notice what I get with that is a negative 60 degrees. So it tells me this is negative 60 here, which is okay. Notice that if I subtract 360 from this, so if I do 360 times negative 1, this will give me a negative 60 degrees. So I've got this one. This could be, I could make this negative 60 plus 360k as a replacement for it. It's the exact same thing. This one, you have to remember that you use the reference angle, 60 degrees with the x-axis, and that, if I go all the way around there, is 240 degrees. So that's how you get the other one. So you can either use your calculator or the unit circle for these problems. You wanna, when you use the notation with the -1 in it, like up here, simplifying, this only gives you one answer. But when you're solving, you've got to remember that you could get multiple answers, and to use this idea of adding 360k on, or if it's tangent or cotangent, adding 180k onto it to get the infinite, in this case, answers in this problem.